All right, section 9.7 talks about tessellations. It's also known as tiling. So you'll see this on the floor, on the ceiling, anywhere where you see tiles as well. What it is, it's a repeating pattern of figures that completely covers a plane without gaps or overlaps. So here's 3 examples of tessellations. One of the most famous tessellators you've probably ever heard of would be MC Escher, if you ever heard of them. Art class, they would usually cover something like that. In order for a figure to tessellate, it must take up all the 360 degrees around a single point with no overlap. So if you look right here, we have 360 degrees covered because 120, 60, 60, and 120 would all add up to 360. There's no gaps and no overlaps. Over here would not be because you see right here there's nothing there, which would be a gap. So that would not be a tessellation. So they have to fit all together like the pieces of a puzzle without gaps or overlaps, all right? So, the questions that they're going to ask you, would a regular 18-gon tessellate? So, the first thing we need to figure out is what one interior angle of an 18-gon is. The way that we're going to do that is we're going to use our formula 180 times n minus 2. N always stands for our number of sides, so in this figure it has 18 sides. 18 minus 2 is 16. So we take 180, multiply it by 16, and we get 2,880. Now that's what all of them add up to. So if I want to figure out what one of them is, I take the 2,880, divide it by the number of sides, which was 18. When we do that, we get 160. So that's what one interior angle would measure, okay? So now we need to figure out if there's any combination of 160 that could equal 360. So the way that we do that is we just take 360 and divide it by 160. When you do that, you get an answer of 2.25. Now, we know this will not tessellate because this has a decimal on it. So whenever it ends with a decimal, they will not tessellate. You want to see whole numbers there. So let's say the answer was 2, then it would tessellate. Or if it was 3, it would tessellate. But the second you get a decimal, it will not tessellate, all right? So let's do these 4 here. An equilateral triangle. So it's a triangle where all sides are equal. So we could use our formula, which is 180 times n minus 2, in this case, 3 minus 2. So we get 180 times 1, which is 180. We need to figure out what one angle is, so we divide by the number of sides, so that's 3. So 180 divided by 3 gives us 60. So if we want to figure out if it'll tessellate, we need to take 360, and we need to divide by 60. When we do that, we get 6. Because that is a whole number, we know that this one will tessellate. Again, if it's a decimal, we know it doesn't, all right? So for number 2, a regular octagon. So we take 180 times 8 minus 2, because an octagon has 8 sides. 180 times 6. When we do 180 times 6, we get 1080. All right, so now to figure out how many degrees each angle is, we take that and divide by the number of sides, which is 8, and we get 135. So to figure out if it'll tessellate, we take 360, divide by 135. When we do that, we get 2.6. You'll notice it has a decimal, therefore we know it will not tessellate. For number 3, you should be able to know this one just because you see this on an everyday basis. If you look at the ceiling or at the floor, squares will always tessellate, but let's go ahead and figure out how to do it. So we take the 180 times, the square has 4 sides, so 4 minus 2. All right, so we get 180 times 2, which is 360. We take 360, we divide it by the number of sides, which was 4, and we get 90. That tells us every angle inside of a square is 90 degrees. So we take 360, divide it by 90, and we get 4. Because that is a whole number, we know that it will tessellate. All right? And then the last one, a hexagon. A hexagon has 6 sides, so we do 180 times 6 minus 2, which is 180 times 4. 180 times 4 gives us 720. Figure out what each angle is, we go ahead and divide that by 6, because that's the number of sides, and we get 120. To figure out if it'll tessellate, we take 360 divided by that one interior angle, and we get 3. Because that is a whole number, we know it will tessellate, so yes, it'll be a tessellation. All right? Make sure you have this completed, and we'll go over it more in class.